Hello everyone, this is an audio recorded lecture for visually impaired students. Here I read class 12th NCERT unit number 13 name amines. The chief commercial use of amines is an intermediates in the synthesis of medicines and fibers. Amines constitute an important class of organic compounds derived by replacing one or more hydrogen atoms of ammonia molecules by alkyl aryl groups. In nature, they occur among proteins, vitamins, alkaloids, and hormones. Synthetic examples include polymers, dyestuffs, and drugs. Two biologically active compounds, namely adrenaline and ephedrine, both containing secondary amino groups, are used to increase blood pressure. Novocaine, a synthetic amino compound, is used as an anesthetic in dentistry. Benadryl, a well-known antihistaminic drugs, also contain tertiary amino group. Quaternary ammonium salts are used as surfactants. Diazonium salts are intermediates in the preparation of a variety of aromatic compounds, including dyes. In this unit, you will also learn about amines and diazonium salts. First, amines. Amines can be considered as the derivative of ammonia obtained by replacement of one, two, or all three hydrogen atoms by alkyl or aryl group. Here is a reaction. Examples of amines: CH3NH2, C6H5NH2, CH3NH, CH3N attached with CH3 and CH3. Here, structure of amines. Like ammonia, nitrogen atoms of amines is trivalent and carries an unshared pair of electrons. Nitrogen orbitals in amine, therefore, sp3 hybridized, and the symmetry of amines is pyramidal. Each of the three sp3 hybridized orbital of nitrogen overlap with orbital of hydrogen or carbon depending upon the composition of amines. The fourth orbital of nitrogen in all amines contains an unshared pair of electrons. Due to the presence of unshared pair of electrons, the angle CNE, where E is C or H, is less than 109.5 degree for instance. It is 108 degree in case trimethylamine as shown in figure, because here nitrogen has one unshared pair of electrons and its shapes become pyramidal shape of triamine. Classification of amines. Amines are classified as primary 1 degree, secondary 2 degree, and tertiary means 3 degrees depending upon the number of hydrogen atoms replaced by alkyl or aryl groups in ammonia molecules. If one hydrogen atom of ammonia is replaced by R or AR, we get RNH2 or ARNH2, a primary amine. If two hydrogen atoms of ammonia or one hydrogen atom of RNH2 are replaced by another alkyl aryl group, what would you get? You get RNHR secondary amine. The secondary alkyl aryl groups may be same or different. Replacement of another hydrogen atom by alkyl aryl group leads to the formation of tertiary amines. Amines are said to be simple when all the alkyl or aryl groups are the same and mixed when they are different. NH3 gives out RNH2 break arrow NH sub NH connected to R and R dash arrow N attached with R dash and R double dash, which is tertiary amine. Nomenclature. In common system, an alphabetic amine is named by prefixing alkyl group to amino, that is alkyl amine, as one word. Example, methylamine. In secondary and tertiary amines, when two or more groups are same, the prefix di or dry is appended before the name of alkyl group. In IUPAC system, primary amines are named as alkanamines. The name is derived by replacement of E of alkane by the word amine. For example, CH3NH2 is named as methenamine. In case more than one amino group is present at different position in the parent chain, their position are specified by giving number of the carbon atoms bearing NH2 group, and suitable prefix such as di, tri, etc. is attached to the amine. The letter E of the suffix of the hydrocarbon part is retained. For example, NH2, CH2, CH2, NH2 is named as ethane 1,2-diamine. The name secondary and tertiary amine we use locate N to designate substituent attached to a nitrogen atom. For example, CH3, NH, CH2, CH3 is named as N-methylamine and CH3, CH2, N is named as N-diethylamine. More examples are given in table. In aryl amines, NH2 group is directly attached to the benzene ring C6H5. NH2 is the simplest example of aryl amine. In common system, it is known as alkaline. It is also an unaccepted IUPAC name. While naming aryl amines according to IUPAC system, suffix E of arene is replaced by amine. Thus, in IUPAC system, C6H5 NH2 is named as benzene amine. Common and IUPAC name of some alkyl amines and aryl amines are CH3, CH2, NH2. Common name ethylamine. IUPAC name ethanamine. CH3, CH2, CH2, NH2 and propylamine is its common name. IUPAC name propane 1-amine. CH3, CH, CH3, CH attached with NH2. Its common name is isopropylamine. IUPAC name is propane 2-amine. CH3 and CH2, CH3. Ethylamine, its common name. IUPAC name is N-methylamine. And the table is continues in this except preparation of amines. Amines are prepared by following methods. First method, reduction of nitro compound. Nitro compounds are reduced to amines by passing hydrogen gas in presence of finely divided nickel, palladium or platinum, and also by reduction with metals in acidic medium. Nitroalkanes can also be similarly reduced to the corresponding alkylamines. Reactions, benzene ring attached with NO2 in presence it reacts in presence of H2PD and ethanol gives out benzene ring attached with group NH2. Here oxygen is replaced. Reduction with iron scarp and hydrochloric acid is preferred because FeCl2 formed get hydrolyzed to release hydrochloric acid during the reaction. Thus only a small amount of hydrochloric acid is required to initiate the reaction. Ammonialysis of alkyl halide. You have read Unit 10, Class 12 that carbon halogen bonds in alkyl or benzyl halides can be easily cleaved by a nucleophile. Hence, an alkyl or benzyl halide on reaction with an ethanolic solution or of ammonia undergoes nucleophilic substitution reaction in which the halogen atom is replaced by an amino NH2 group. This process of cleavage of CX bond by ammonia molecule is known as ammonialysis. The reaction is carried out in a sealed tube at 373 Kelvin temperature. The primary amine thus obtained behaves as the nucleophile and can further react with alkyl halide to form secondary and tertiary amines and finally quaternary ammonium salt. NH3, a nucleophile, reacts with RX gives out RNH3X negative substituted ammonium salt. RNH2 reacts with RX gives out R2NH. Again it reacts with RX gives RN3 R3N. Again reacts with RX. Here it gives R4 N positive X negative, which means quaternary ammonium salt. The free amine can be obtained from the ammonium salt by treatment with a strong base. RNH3 positive charge X negative charge reacts in presence of NaOH, which is a strong base, gives out RNH2 plus H2O plus N positive X negative. Ammonialysis has the disadvantages of yielding a mixture of primary and secondary and tertiary amines and also a quaternary ammonium salt. However, primary amine is obtained as a major product by taking large excess of ammonia. The order of reactivity of halides with amine is Ri, Rbr greater than RCl. Next preparation method, reduction of nitriles. Nitriles on reduction with lithium aluminium hydride LiAlH4 or catalytic hydrogenation produce primary amines. This is reaction used for ascent of amine series, that is for preparation of amines containing one carbon atom more than the starting amine. RC triple bond N reacts in presence of H2O nickel NaHg slash C2H5OH, gives out RCH2NH2. Reduction of amides. The amides on reduction with lithium aluminium hydride yields amines. RC double bond O NH2 reacts in presence of LiAlH4 and water, gives out RCH2NH2. Next reaction is Gabriel thalamide synthesis. Gabriel synthesis is used for the preparation of primary amines. Thalamide on treatment with ethanolic potassium hydroxides forms potassium salt of thalamide, which on heating with alkyl halides followed by alkaline hydrolysis produces the corresponding primary amine. Aromatic primary amine cannot be prepared by this method because aryl halide do not undergo nucleophilic substitution with the anion formed by thalamide. It is a method to prepare 1-degree amine 6 process Hofmann bromamide degradation reaction. Hofmann developed a method for preparation of primary amines by treating an amide with bromine in an aqueous or ethanolic solution of sodium hydroxide. In this degradation reaction, migration of an alkyl or aryl group take place from carbonyl carbon of the amide to the nitrogen atom. The amine so formed contains one carbon less than that present in the amide. Physical properties. The lower aliphatic amines are gases with fishy odor. Primary amines with 3 or more carbon atoms are liquid and still higher ones are solid. Aniline and other aryl amines are usually colorless but get colored on storage due to atmospheric oxidation. Lower aliphatic amines are soluble in water because they can form hydrogen bond with water molecules. However, solubility decreases with increase in molar mass of amines due to increase in size of the hydrophobic alkyl part. Higher amines are essentially insoluble in water. Considering the electronegativity of nitrogen of amines and oxygen of alcohol as 3.0 and 3.5 respectively, you can predict the pattern of solubility of amines and alcohol in water. Out of butane 1-ol and butane 1-amine, which will be more soluble in water and why? Amines are soluble in organic solvent like alcohol, ether and benzene. You may remember that alcohols are more polar than amines and form stronger intermolecular hydrogen bond than amines. Primary and secondary amines are engaged in intramolecular association due to hydrogen bonding between nitrogen of one and hydrogen of another molecule. This intermolecular association is more in primary amines than in secondary amines, as there are two hydrogen atoms available for hydrogen bond formation in it. Tertiary amines do not have intermolecular association due to the absence of hydrogen atom available for hydrogen bond formation. Therefore, the order of boiling point of isomeric amines is as follows: primary amine, then secondary amine, and then tertiary amine. Intermolecular hydrogen bonding in primary amines. Boiling point of amines, alcohol and alkynes of almost the same molar mass. Chemical reactions. Difference in electronegativity between nitrogen and hydrogen atom and the presence of unshared pair of electrons over the nitrogen atom makes amines reactive. The number of hydrogen atoms attached to nitrogen atom also decides the course of reaction of amines. That is why primary amine, secondary amine and tertiary amine differ in many reactions. Moreover, amines behave as nucleophiles due to presence of unshared pair of electrons. Some of the reactions of the amines are described as basic character of amines. Amine being basic in nature reacts with acid to form salt as RNH2 plus HX. It is a reversible reaction, gives out RNH3 positive X negative, which is salt. Aniline benzene ring attached with NH2. Here N has one unshared pair of electrons plus HCl gives out NH3Cl negative aniline chloride. Amine salt on treating with base like NaOH generate the parent amine. RNH3 X negative plus OH negative gives out RNH2 plus water plus X negative. Amine salts are soluble in water but insoluble in organic solvent like ether. This reaction is the basis for the separation of amines from the non-basic organic compounds insoluble in water. The reaction of amines with mineral acids to form ammonium salt shows that these are basic in nature. Amines have an unshared pair of electrons on nitrogen atom due to which they behave as Lewis base. Basic character of amines can be better understood in terms of their Kb and Kbb value as explained below. RNH2 plus H2O gives out reversible reaction RNH3 positive plus OH negative. K is equal to here K is equal to product upon में reactant concentration RNH3OH negative upon में RNH2 bracket close H2O or to find out key value of H2O is equal to RNH3OH negative divided by upon में RNH2 or Kb is equal to RNH3OH negative upon RNH2. pKb is equal to minus log Kb. Larger the value of Kb or smaller the value of pKb, stronger is the base. The pKb value of few amines of ammonia is 4.75. Aliphatic amines are stronger base than ammonia due to plus I effect of alkyl group leading to high electron density on nitrogen atom. Their pKb value lie in the range of 3 to 4.22. On the other hand, aromatic amines are weaker bases than ammonia due to electron withdrawing nature of aryl group. pKb values of amines in aqueous phase. Methenamine 3.38, N-methyl methenamine 3.28, N-dimethylamine 4.22, ethenamine 3.29, N-ethyl ethenamine 3.00, N-diethylamine 3.25, benzaminamine 9.38, phenylmethenamine 4.70, N-methylaniline 9.30, and N-dimethylanilane 8.92. You may find some disappearances while trying to interpret the Kb values of amines on the basis of plus I or minus I effect of the substituents present in amines. Besides inductive effect, there are other effects like solvent effects, steric hindrance, etc., which affect the basic strength of amines. Just ponder over. You may get the answer in the following paragraph. Structure, basicity, relationships of amines. Basicity of amines is related to their structure. Basic character of an amine depend upon the isoformation of cation by accepting a proton from the acid. The more stable the cation is relative to the amine, more basic is the amine. Alkanamines versus ammonia. Let us consider the reaction of alkanamine and ammonia with a proton to compare their basicity. RNH2 N with one lone pair plus H gives out RNH3 N with positive charge. NH3 one lone pair plus H positive charge gives out in a reversible reaction NH4 with positive charge. Due to the electron releasing nature of alkyl group, it R pushes electron towards nitrogen and thus makes the unshared electron pair more available for sharing with the proton of acid. Moreover, due to dispersal of positive charge by by the plus I effect of the alkyl group. Hence, alkyl amines are stronger bases than ammonia. Thus, the basic nature of aliphatic amines should increase with the increase in the number of alkyl group. This trend is followed in gaseous phase. The order of basicity of amines in the gaseous phase follows the expected order: tertiary amine, secondary amine, and primary amine, and then ammonia. The trend is not regular in the aqueous state, as evident by their pKb values. In the aqueous phase, the substituted ammonium cations get stabilized not only by electron releasing effect of the alkyl group plus I, but also by solvation with water molecules. The greater the size of the ion, lesser will be the solvation, and the less stability is the ion. The order of stability of ions are as follows: 1 degree, then 2 degree, and then 3 degree. Decreasing order of extent of hydrogen bonding in water, and order of stability of ions by solvation. Greater is the stability of the substituted ammonia cation, stronger should be the corresponding amines as a base. Thus, the order of basicity of aliphatic amines should be primary, secondary, tertiary, which is opposite to the inductive effect base order. Secondly, when the alkyl group is small like CH3 group, there is no steric hindrance to H bonding. In case the alkyl group is bigger than CH3 group, there will be steric hindrance to H bonding. Therefore, the change of nature of the alkyl group, example from CH3 to C2H5, result in change of the order of basic strength. Thus, there is a suitable interplay of inductive effect, solvation effect, and steric hindrance of alkyl group, which decides the basic strength of alkyl amines in the aqueous state. The order of basic strength in case of methyl substituted amine and ethyl substituted amine in an aqueous solution as follows: 3 to H5 whole bracket 2 NH3 greater C2H5 whole bracket 3 and greater C2H5 NH2 greater than NH3. Aryl amines versus ammonia. pKb value of aniline is quite high. Why it is so? It is because in aniline or other aryl amines, the NH2 group is attached directly to the benzene ring. It results in the unshared electron pair of nitrogen atom to be in conjugation with the benzene ring, and thus making it less available for protonation. If you write different resonating structures of aniline, you will find that aniline is a resonance hybrid of the following five structures. On the other hand, any lithium ion obtained by accepting a proton can have only two resonating structure, also called cacule. We know that greater the number of resonating structure, greater is the stability. Thus, you can infer that aniline 5 resonating structure is more stable than anilinium ion. Hence, the proton acceptability of basic nature of aniline or other aromatic amines would be less than that of ammonia. In case of substituted aniline, it is observed that electron releasing group like OCH3, CH3 increase basic, whereas electrons withdrawing group like NO2, SO3H, COOH decrease it. Alkylation. Amines undergo alkylation on react with alkyl halide. Acylation. Aliphatic and aromatic primary and secondary amines react with acid chlorides and hydrides or esters by nucleophilic substitution reaction. This reaction is also known as acylation. You can consider this reaction as a replacement of a hydrogen atom of NH2 or NH group by the acyl group. The product obtained by acylation reaction are also known as amides. The reaction is carried out in presence of a strong base than the amine, like pyridine, which removes HCl so formed and shift the equilibrium to the right hand side. Here ethanamides reacts in presence of base, gives out an intermediate, then after again reaction further reactions it provides us an ethyl amide. Amines also react with benzyl chloride. This reaction is known as benzylation. Methenamine plus benzyl chloride gives out N-methyl benzenamide. Why do you think is the product of the reaction amines with carboxylic acid? They form salts with amines at room temperature. Carbyl amine reaction. Aliphatic and aromatic primary amines on heating with chloroform and ethanolic potassium hydroxide form isocyanates or carbyl amines, which are foul smelling substances. Secondary and tertiary amines do not show this reaction. This reaction is known as carbyl amine reaction or isocyanate test and is used as a test for primary amines. RNH2 plus CHCl3 plus 3KOH heat RNC plus 3KCl plus 3H2O. Reaction with nitrous acid. Three classes of amines react differently with nitrous acid, which is prepared in situ from a mineral acid and sodium nitrite. First, primary aliphatic amines react with nitrous acid to form aliphatic diazonium salts, which bring unstable liberated nitrogen gas qualitatively and alcohols. Quantitative evolution of nitrogen is used in estimation of amino acids and proteins. RNH2 plus HNO2 in presence of NaNO2 plus HCl reacts gives out Rn2 positive charge Cl negative. Again in reaction of H2O reacts and provides ROH plus N2 plus HCl. Aromatic amines react with nitrous acid at low temperature to form diazonium salts, a very important class of compound used for synthesis of a variety of aromatic compounds. Aniline C6H5NH2 in presence of NaNO2 plus 2 moles of HCl at temperature 273 to 278 Kelvin gives out C6H5N2 positive Cl negative benzyl diazonium chloride plus NaCl and plus 2 moles of water. Secondary and tertiary amines react with nitrous acid in a different manner. Reaction with aryl sulfonyl chloride. Benzene sulfonyl chloride C6H5SO2Cl, which is also known as Heisenberg reagents, reacts with primary and secondary amines to form sulfoamides. The reaction of benzyl sulfophenyl chloride with primary amines yield an ethyl benzene sulfonyl amide. The hydrogen attached to nitrogen in sulfonamide is strongly acidic due to presence of strong electron withdrawing sulfonyl group. Hence, it is soluble in alkali. In the reaction with secondary amine, an n-diethylbenzyl sulfonamide is formed. Since an n-diethylbenzene sulfonamide does not contain any hydrogen atom attached to nitrogen atom, it is not acidic and hence insoluble in alkali. Tertiary amines do not react with benzoyl sulfonyl chloride. This property of amines reacting with benzyl sulfonyl chloride in a different manner is used for the distinction of primary, secondary, and tertiary amines, and also for the separation of a mixture of amines. However, these days benzyl sulfonyl chloride is replaced by paratoluene sulfonyl chloride. Electrophilic substitution. You have read earlier that aniline is a resonance hybrid of 5 structure. Where do you find the maximum electron density in this structure? Ortho and para position to the NH2 group become centers of high electron density. Thus, NH2 group is ortho and para directing and a powerful activating group. Bromination. Aniline reacts with bromine water at room temperature to give a white PPT of 2,4,6 tribromoaniline. The main problem encountered during the electrophilic substitution reaction of aromatic amines is that of their very high reactivity. Substitution tends to occur at ortho and para position. If we have to prepare monosubstituted aniline derivative, how can the activating effect of NH2 group be controlled? This can be done by protecting the NH2 group by acetylation with acetic anhydride. They carried out the desired substitution followed by hydrolysis of the substituted amide to the substituted amine. Aniline in presence of CH3CO whole twice 2O pyridine reacts to form N-phenylethamide. Again, in presence of Br2CH3COOH reacts to form 4-bromoaniline, which is a major product, and second one after reacting OH negative or H positive it forms 4-bromoaniline, which is minor product. The lone pair of electrons of nitrogen of acetonide interacts with the oxygen atom due to resonance. is the lone pair of electron on nitrogen is less available for donation to benzene ring by resonance. Therefore, activating effect of an HCOCH3 group is less than that of amino group. Nitration. Direct nitration of aniline yields oxidation product in addition to the nitro derivatives. Moreover, in the strongly acidic medium, aniline is protonated to form the aluminium ion, which is meta directing. That is why besides the ortho and para derivatives, significant amount of meta derivatives is also formed. Aniline in presence of HNO3, H2SO4 at temperature 288 kelvins gives out 51% product of an benzene ring attached with NH2NO. Again, it says para directing group 47% meta directing group, 2% product of ortho directing group. However, the protecting the NH2 group by acetylation reaction with acetic anhydride, the nitration reaction can be controlled and the para nitro derivative can be obtained as the major product. And in presence of CH3CO or twice 2O pyridine gives out NH acetanilide in presence of HNO3 H2SO4 288 temperature gives paranitroacetanide and paranitroaniline after reacting with OH or H positive. Sulfonation. Aniline react with the concentrated sulfuric acid to form anilinium hydrogen sulfate, which on heating with sulfuric acid at 453 to 473 Kelvin produces para-aminobenzene sulfonic acid, commonly known as sulfonylic acid, as the major product. Aniline does not undergo Friedel-Crafts reaction, alkylation and acetylation due to salt formation with ammonium chloride. The Lewis acid, which is used as the catalyst due to this nitrogen of aniline, acquires positive charge and hence act as a strong deactivating group for further reaction.